There's been a lot of talk about next generation firewalls and their ability to go deep into a packet at the application layer to see what's really going on. Well, a big step in allowing that firewall to go deep into those packets is to set up application layer based security policies. In this nugget, you and I are going to chat about what our options are and then why it's so important to give the firewall an opportunity to go deep. Have you ever had one of those moments where you go, oh, I see? Well, prepare yourself. We're going to have another one of those right now. In earlier nuggets, we set up network address translation rules and security policy rules for permissions. And our two specific examples were we netted the server to the outside, and we had a security policy that allowed users on the outside to go ahead and access that web server if they were using HTTP. That's rule number 2 right here. We also did dynamic PAT for users on the inside going to the outside, and we set up a security policy for allowing traffic to go from the inside to the outside. And that's our security policy in this output of security policy number 1. And what I'd like to have you focus with me on for just a moment is these two columns right here, application and service. And let's focus our attention on the security policy rule, rule number 2, that allows user like Lois on the internet to go ahead and connect to the server via web services. And the rule says this: permit traffic if sourced on the outside zone, meaning it's coming in on this interface that's associated with that outside zone. It can come from any source IP address. So Lois's IP address could be anything based on this policy. If the destination zone is the DMZ, which is where this server is connected, it's on an interface that's associated with the DMZ. And if the destination is 192.168.1.251, that is the pre-NAT address as part of the security policy. So the security policy is going to use the first IP address or the global address that Lois is going to hit as part of that security policy. And then under application, notice it says any, and then under service it says service HTTP. Now, if we were to look at this service object, which we're going to here in just a moment, called service-HTTP, it would indicate that it's expecting TCP, and for the port, it's expecting the well-known port of 80 or 8080. And that's what this service-HTTP describes. And in our rule, we said if that all matches up, please allow that traffic. Now, I've got a question for you. What is the intent for you and I regarding Lois and this web server? And you might say, Keith, what do you mean, what is our intent? And what I'm after is, what's the real purpose? And the real purpose in a production environment would be we have some service, very likely a real web service, that we want Lois to have access to. But what if Lois, taking an assortment of tools, and for example, Kali Linux has hundreds and hundreds of attack tools. What if Lois gets one of those tools and creates a malicious payload and a whole bunch of malicious content that's not even HTTP? But at the same time, she still puts on a TCP header destined for TCP port 80. If the firewall just has this rule saying, well, I'm just looking for the protocol and port for TCP port 80 or 8080, that security policy is going to allow that traffic through. It's like looking at the outside of an envelope and saying, yep, it's addressed here, I'm going to send it. So whenever we're doing a security policy that's based solely on the service, we're basically filtering on protocols and port numbers, but pretty much we're stopping at layer 4 from a protocol perspective, and we're not looking any further. We're just looking at the outside of an envelope for our decision-making process. And what that could lead to is the attacker sending in malicious attacks and potentially getting those through the firewall because at layer 4 it is TCP in our example and port 80. The other challenge we have with not looking any deeper than the transport layer in the protocol stack is that we lose our ability to be very granular. For example, we may want some type of services over TCP port 80 to be allowed, while other functions or features perhaps not be allowed. And with a next generation firewall, we want the capability of doing application layer granular filtering. So we're allowing some types of applications and services over TCP port 80 and not others. And the challenge is when we stop at the transport layer and we're only making decisions based on that, we're not giving the firewall the opportunity to dig into the payload and take a deeper look at what's really happening inside of that packet, up at the application layer, deeper into the payload of that packet. So let's contrast that with rule number 1, which is right here, which is allowing Bob and everybody on the inside from the 10.1.1 source network to go out to the internet. So here's the name of our rule, and it's regarding people who are sending packets that are coming in on an interface that's a part of the inside zone. If their source address is 10.1.1, and we used an address object for that, and if their traffic is being routed out of an interface that's a member of the outside zone, and the destination IP address can be any IP address out here on the internet. And notice here in the application column about the difference. Here we're specifying some applications that the Palo Alto firewall knows about. And this, by the way, is the preferred method of setting up our security policies. It's based on application as opposed to just the protocols and ports, the services. Because when we use the DNS application object in our security policy, the Palo Alto firewall knows that it's UDP port 53, but it also knows that in the payload of this UDP packet destined for the server on port 53, that it should be a DNS request. It knows how to look for that specific type of traffic. So now if Bob or some other user is trying to send a packet that at layer 4 is UDP, and it's using the well-known port of 53, but it's not a DNS request, it's something else, maybe the user is attempting to maliciously tunnel traffic and get it out of the network, disguising the transport layer to make it look like a UDP request. Because the Palo Alto knows what the DNS request looks like, it can say, hey, this isn't DNS, and it can stop it and not allow it out. Another example that we did was ping. Now, ping uses ICMP, which is protocol number 1, and inside of a ping request, it should look like a ping request. And if the payload isn't a ping request, because we're doing application layer inspection here, the Palo Alto firewall can say, wait a second, this is ICMP, but the payload is all whacked out. This is not a ping request. And as a result, it can prevent that from going out. We also set up SSL, which is going to be a little bit different because SSL is setting up a secure session between the client and the outside resource. So unless we train the firewall to step in and become a man in the middle, which, by the way, we'll do in this course in another nugget, the session between Bob and the external resource is going to be secure, but still in the setup and negotiation of that SSL session, there's going to be a three-way handshake with TCP, and the firewall has a pretty good idea of what that setup should look like. So if there's some funny business going on or some things that aren't standardized, the firewall can shut that stuff down so it doesn't happen. And then for the web browsing application, that's going to include the knowledge of TCP and port 80, in addition to being aware of what the payloads and negotiations and content should look like. And then for all these, by default, for the service, it said application default. And what the application default means regarding services, it's going to use the well-known and expected ports associated with these application objects. So the question may come up, why does this matter? And the answer is, if we want the next generation firewall features, such as being to granularly inspect application layer data. Maybe we want Bob, as he goes out to Facebook, to be able to use some parts of Facebook, but not others. We can go ahead and control that. For example, if we don't want Bob to use a file transfer feature, or a chat feature, or play a game, we can specify those policies on the Palo Alto firewall. And the other cool thing about having a Palo Alto firewall is besides the application granular control that we can also tie those conversations into the actual user. So at the end of the day, not only are we controlling our policy, but we also have great logging capabilities to identify that, like the game Clue, where we can identify it was Colonel Mustard in the library with the pipe who committed the crime. We can get very granular to see which users associated with which IP addresses were attempting what activities, which is very, very helpful when we're trying to track down and make sure that our security policies are being complied with. So we can kind of think of doing application layer security policies as being the gateway drug into more advanced control and filtering, because we're giving the firewall the opportunity to look deeper into the content, deeper into the payload, to see exactly what's going on as part of the traffic that it's allowing to course through the veins of this firewall. So here in the graphical user interface, if we went to the Objects tab, over here on the left, if we click on Applications, it's going to show us all of the applications that Palo Alto has identified. There's over 2,000 of them currently, and as time goes on, that number is going to grow and grow. So we could do searching here. It's also sorted by name down here. So if we go all the way to the bottom and all the way to the end, which is page 36, and then maybe just go back a couple pages to the W's, which is the application object. that we used as part of our security policy for our end user. So if we click on web browsing, it brings up the details for this object. It tells us looking for TCP port 80. So that's the application default port for a server request going to a web server. It also has links for Wikipedia, Google, and Yahoo. It's got some characteristics, classification, and options regarding it as well. Still under objects, if we go over to the left and we select services, there are two default services on this firewall. They're called service-HTTP and service-HTTPS. We use this service, called service-HTTP, as part of our security policy when we specify that we wanted to allow users on the internet to access our DMZ resource, which was our web server. And by default, this service-HTTP is looking for TCP port 80 or 8080. And again, the negative of just using port and protocol-based permissions is that we're limiting the application inspection that could be done by the firewall, which could give us more granular application control as that firewall allows traffic through the firewall. So let's do a recap. In a security policy regarding permissions, we can do it based on application, which is the best way and preferred way of doing it, because it gives the firewall a chance to do deeper inspections. We can set up additional controls based on the content in the packets, or we can do it based on just protocol and port, at which point we'd be using services and service groups to identify the protocols and ports that we want to allow. And the question might come up, well, why are there two ways of doing it? And the answer is we may have specific needs for doing just protocol and port filtering, which is certainly going to take less overhead on the firewall. But at the same time, when we want to have the features of deep packet inspection and analyzing the application layer content in those packets, we're going to want to use the application layer inspection aspect inside of our security policies. I am glad you joined me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.